Hi, everyone. Welcome to ASTRO's ASTRO GoTub webinar today. We did push it out a week later, so thank you all for coming.
Nicole, you've muted yourself, and perhaps you want to say you're Nicole Henson and you just muted yourself, but
Thanks, Penelope.
now you're back.
I pressed the wrong arrow, so it did the mute instead of just the arrow. I hope the welcome part, but I am Nicole Hanson.
We heard your welcome.
Okay, great. So I'm Nicole Hanson. I work for Idaho Transportation Department in their GIS group, and I'll say more there later, but GoTug was started back in September 2015 with Utah, with UPlan and all that, and just finding out so we can find innovative ways to continue using geospatial data online, like getting everyone involved. There we go. So the main goals of GoTug is bringing together everyone from all walks of life in the transportation arena, the GIS, engineering disciplines, just everyone coming together so we can have better, see what other other states, other cities and counties are using their stuff online and how we can maybe better use it for our own agency. The key people, we have our committee chair, which is Jeremy Acock. He is with the North Carolina DOT, and our ASTRA liaison is Penelope. She's the one that keeps telling me what to do, so which is awesome. We also have our steering committee. We have representatives from a few different areas, as you can see. Adrian from Utah DOT and Andrew from the Texas Transportation Institute, myself, and Mark. Sorry, Mark, you're going Mark. Mark from FHWA. So our webinars, they are hosted quarterly. Generally, they are the first Wednesday of March, June, September, and December. So our next one will be in December, and I'll have more about that here in a little bit later at the end of this whole webinar. So please stay on for a few more minutes at the end. And our webinars, we have them generally like a theme for each one, but each month, each of the webinars are different. We try to get a variety going. So if you have ideas and want to present, email Penelope or Jeremy, and they will be happy to add you to our repertoire of webinars. You can view past webinars if you're curious what things have been talked about and what haven't. So this is our website that you can go to. If you don't want to write the website down, you can also Google GoTug Transportation, and it will take you here. We do have a distribution list where you can get updates and find out about webinars that are upcoming. And these are a few other resources, FHWA's and PO working group websites that we partner with. So the next webinar is going to be December 2nd. And it'll be featuring some more presentations that weren't able to happen at JST this year. We've actually been asking a lot of the presentations that we'd seen that were like, oh, they do a lot of stuff with the online. So we're like, hey, this will be perfect for GoTug. So you're going to be hearing a lot of those here in the next couple webinars. Okay, today's presentation, what you guys came to listen to, and it wasn't just me. First, we're going to have from Georgia DOT, Hong Ling. She is going to be talking about a streamlined full digital emergency operations center mapping application, which her description of it just sounded really awesome. So I know you guys are going to be really excited. Actually, all of these were just really stood out to us. And I'm really glad that they were able to be here. So I'm going to turn it over to Hong. See if I can. Actually, Penelope, will you change it? I don't want to screw it up.
Yes.
Thank you.
Don't forget to unmute yourself before you start presenting.
Right. Thank you, Penelope, for the reminder. All right. Can you see my screen?
Yes, looks great.
Okay. All right, let's get started. Right. Good afternoon, everyone. My name is Hong Liang. I'm the JS team lead managing G.IT Enterprise JS team. Today, it's my pleasure to present the web-based Emergency Operation Center mapping applications. We call it WebEOC map that embrace a streamlined full digital process for logging and reporting real-time road incident data. Okay. So here's the overview. I think I got the first page. Okay. Right, that's first page. Right. So
We're looking.
yeah, you're looking at the overview now. Yeah. So
Yes.
WebEOC serves as a central emergency information system that is by design to collect, store, and manage road incident data. I will have two cases as example to demonstrate how this very mapping application can simplify and streamline the process. The first case is when you have an incident blocking a specific segment of the road. You need to log it and present it to the EOC center so that the center can act accordingly. And the second case is when road condition changes in large area. How do we handle the regional road condition mapping that allows local authorities and the other governments to coordinate their actions? And I have a few slides to explain the process. There are static screenshots on the slides coming up to show the steps. Then followed by live demo. Hope the internet connection can catch up with my pace during the live demo. Okay. So here comes the first case. When you are a user to log an incident, you start with opening this new incident form showing on the slide as a screenshot, and you can see you're provided with three options or three different ways to get the incident location. Here is the JS first and logging instance per route segment, and then second option is logging the incident, the street address, and third one is logging incident per longitude and latitude. And lat long option and address geocode options are straightforward. And let's take a look at the route geocode option. We need some explanation for route geocoder. And you can see on the screen capture, users have the county list. And after I select the route geocode, the user has the county list pop up. And then sequentially, user is asked to select a route number inside the selected county. There's a list of routes inside this county you can select from, and each item on the route and the route list carries the length in mile, and then you fill in the beginning and end of the impacted route segment. And I put here as example, I put a 5 mile begin point starting from 5 miles, and then the end mile point is 12. So after they click the retrieve info button, and the incident location information segment here will be automatically populated. All the fields are grayed out. That means you are not able to modify. Everything is automatically populated. And then you fill up the incident details and continue to create this incident. Somehow I'm seeing the screen share is now paused. Penelope?
Yeah, I'm getting a lot of messages that people are not seeing the screens also, so I am wondering what's happening. Ah,
I can reshare it.
yeah, try refreshing maybe. Can you refresh, Hung?
Yep, let me try. Refresh.
I mean, it says you're connected and it says you're sharing your screen, but have you advanced the screen? Or you?
Yeah, this is my screen. I can see it.
So in the upper right-hand corner of the controls, it says audience view. Can you open that and see what we're seeing?
It's 100%. I can see audience view is 100%. Well, I don't see
No, not the
anything.
dashboard, up above that.
Mm.
Here,
Yeah, I see a black box there. So let's restart the sharing.
You'd stop sharing and start sharing again. That would be good.
Yeah.
Bear with us. We're having technical difficulties. And of course, I set the time wrong. So everyone thought we started at 12:45, but we started at 1. So I apologize for that. But I'm glad that we have great attendance today. We have 80 people. So did you stop sharing and start sharing again?
Yeah, I try.
Let me change presenters and
I
I'll
cannot.
again. I'm going to change it back to you. Hopefully that'll work.
Mhm.
All right. Can you show your application?
Yep. Can you see?
No. We just see the overview screen. All right, I'm going to go ahead and try and show your PowerPoint instead, okay?
Can you try it right now? Can you see it? No.
No. It'd be easier if I do it, I think. Just give me 1 sec. Again, I think I'm going to have to show it with your notes, though. All right.
All right. That's fine. I can just go ahead and read it.
How's that?
Yeah.
Is this
That's
the slide
good.
you want to be on?
The third one. Yeah, we can start from the third one.
Okay. Is this the third one? Slide 3.
Yes, slide 3.
Okay.
The new incident form to log an incident.
All right. The incident table or the new incident form? There
New
we go.
incident form.
Are you seeing it?
Okay. Strangely, yeah, I'm seeing it here.
Okay.
Okay. Yeah, that's fine. So that's we talk about. I have two cases to do the demonstration, and showing how do we simplify and streamline the process to log a single incident or to mark the condition change in a large area. So this is the first case we talk about that. When you are to log an incident, you start with opening this new incident page, and then you can see you have three options here. And the first option is route geocoder, and then followed by address geocoder, and then longitude latitude geocoder. Lat long and address geocoder is quite straightforward. We want to look into the route geocoder option, and we also want some explanation about how do we use this and how does it work. And then the user have a county. I already select the first one, so user have a county list to select, and sequentially, yeah, you will be pop up. You have the route state route number pop up as a list, and you select any route inside this selected county. And then you will specify with the begin mile point and the end mile point to make the range on top of this route. Okay. And after that, you click the retrieve information button, and the instant location information section, the second segment, will be automatically populated with all those information by calling the backend server service. So the fields are grayed out because you are not allowed to modify them. It will automatically have route info and all those specifications there. And now by then, you also can fill in other instant details and go further and finish the required fields and click create it. Now you create a new incident, and the window will close. And then you see this incident table here, which already showing on the share screen. Now, inside this table, you see the newly created entry. This is the main table. You see the newly entry created is colorful because it represents different status, and you can find out that each entry you can go view it and open, get the details and print it out, or you can update with most recent information and save it again. And furthermore, you have one more map link next to the instant line, instant name. You click it and launch stand along the map application, and see how this instant displayed on the map, which is the next slide. So we create this instant using the geocoder option. That means we already have the route info and the segment, the range of this segment being impacted by this specific incident. Next slide, please. All right. So this one, you will be brought to this instant map after you click the map link, and then you select, and the incident select to see is showing on the map and represent as the diamond shape. And then you see a line underneath the diamond shape. That's the range you specified when you create the incident. And of course, you can click to bring up the pop-up info, and then this just represent the range of the again. And the route segment is highlighted. It's supposed to be red dots along the route, and there's a polyline shape. And yeah, the node says I created yesterday. Yeah, for the demo, the time and showing that. All right, so this is the create a single incident case, and then we'll take a look at the second case. It's about to map the route condition in a large area. Next slide, please. Okay, thank you. So under certain scenario, always there's a case that the whole area is being blocked and not accessible to the public traffic. and we know exactly which area, and we know which district, and even we know within this district which county, and specifically which route or multiple routes within this county are not available, are not accessible. So how do we do this, marking the condition and show it on the map at once? We can go one by one to mark the condition change, or can we do it at once because we already have all those information? So it can allow us to mark on the map as soon as possible for the decision makers and the local authorities to signify and then coordinate their actions. So let me explain how can we do that. And we did prepare. That's why we have this digital mapping, and all the routes at once can be in different scale and different condition. And then the next slide will show you actually the same slide on here. The second if you can zoom in more, that's not a full slides, but if you look at the setting up the map status here on the same slides, the second screenshot, you will have the option about selecting which district, and then after you select district, you have a list of the counties within district cascade case, and you go further select county and then specify one single route or multiple routes and pick the status, and then click the update and close it. Next slide, please. All right, here, and this slide is how the status condition be marked. And so on the map for a whole county, see the county in red color, that means locked. And all those green lines cover the whole state. They are in good condition, it's accessible, open to the public. And we do have flexibility here to map the specific route though, but you have to do it a whole route within the county, use the county boundary. So that's current case. And as you can see, we also in the live demo will show you one district can be marked as a block using the red lines. All right. I think that pretty much the slides I can use to explain the steps, and we still have some time here. And the last is, yeah, this is the live demo now. If see how far we can go, but yeah, let me share my screen.
I've made you the presenter again, so let's see if we can see the live demo. Everyone cross your fingers.
I'll just show my screen. Can you see well?
Yes, I can see it. Can everyone see Georgia Transportation Emergency Management Major Incidents screen?
I just shared the whole screen. All right, I'll assume everybody can see my screen here.
Looks like everyone can see it.
Okay, that's good. So this is the main dashboard. You see that the grid, the instant grid here. And I created this incident yesterday, so I can see it's showing up here because it's past the time, so it turned into different color. So let's start with this create a new incident. This is the screen. I had a screenshot on the slide. This is the incident management form. There are the three options. Remember, the first one is route geocoder. And if you don't click, you don't see all these county and state route numbers. And you pick the first one, you have this option to select from, say, the Forsyth County. Getting all the lists for the Forsyth County, all the route list, and within this Forsyth County, you have this the route I picked, the 400, and have been marked with begin and end the whole route range, and I specify, for example, 5, let's say 1 is the begin map point, 5 is end map point, and retreat. Remember here, you see all those are blank. Now I retrieve information, it's calling the service and getting the information up and pop up and populate all those fields. You keep going and fill out all those information. Since I already created the instance yesterday, we can go back. So once you create it, you will see the new entry being inserted into the grid. Now we can use the one already created. Let's see if I can move here a little bit. All right, so the first one example, you can view it and all those already, and go ahead, print it out. So that's how you get more information, and then you can update as well. It will repopulate the same form, and you just update the form and click save. And then the interesting thing is you click the map here. There's a waiting time because it's our QA environment, it's not production. Already have some. Okay, it's getting. All right, since that's a range, I'll expect a little bit delay here. Yeah, so this is the selected as incident, and the range already being marked with the red dot line. That's the incident. So that's how you see the location. Zooming in, zoom out is a very general map navigation function here. Then go back to, that's the first case. And the second case is about the large area condition mapping. So there's an option here. I already have, yeah, G dot state. The screenshot on my slide is quite small because we cannot describe the full slides. So the first screenshot is the overview, give you the instruction, and inside there's a small link, how do you use that for the first time user, and then this is the map status change site. Do it here. If I can minimize that, be great. But the district, see, we have 7 districts. You pick any of them. Cascade. Sorry. So there's a list of the counties within this district 4. You pick linear, and with this selection, you will see the state route being populated. Okay, automatically you specify which one you want to make the change, or multiple states, multiple routes, and change the status, the list of status, and you submit that. For now, I already made the change to save our time. I have this, let me see the status. Okay, so here you can see it's by, based on the boundary, the status being changed. Red color represent a block status, and the green represent the open status, and you use the pop-up, the last window to control the color and control the area you want to change the color for the route color. So that's pretty much about it. And it's quite straightforward. You can print out this page. This point, we have a print function and change the different background and have a nice print out about what happened, what status to show to the authorities. All right, I think pretty much that's all I want to share with you all. Thank you for this opportunity. I really enjoy this presentation.
There are a couple questions for you. So let me ask you a couple questions and then we're going to move on to the next presentation. But one question is, are these incidents related to construction projects? How do users know the station value or coordinates where the incident occurred?
Right, it's not necessarily related to construction, but we have a field crew outside during the emergency event, and they can report, they know where it is, and they so far if they use their mobile version, they can go log directly there, and or they can come back to our office personnel and operators and log us through this web application.
Okay, and then there's another question. Is this incident management used by the Traffic Management Center staff?
Yes, they can do that. Yeah, currently they log the daily incident through this system for their reporting usage or for their other analysis usage. Yes.
And then the next question and comment is, I imagine this is transactional incidents. Do you have the ability to recreate an incident that occurred before for review purposes?
Yes, anytime. This is, if I understand the question correctly, yes, anytime you can recreate the incident. That's no time limit, but you need to specify. I mean, you can update it. That's the purpose. If you create an incident, you can update it with most current information, or if it's a new instance, you go ahead and use the instant form to create another one.
All right. Thanks so much. I'm going to switch the presenter back to Nicole. She's going to introduce the next session. And if there are more questions and we have time at the end, we'll go ahead and come back to this presentation. But right now, I think we're going to talk. I'm turning it over to Nicole. Nicole, don't forget to unmute.
Already done. So next up is Glenn Vorsch from University of Wisconsin, and he'll be talking about the crash mapping and analysis data system structure. So that's all I have about his. Let's get him changed over. Oh, I figured it out. Okay, Glenn, you're up.
Okay, an audio and a screen test. How are things looking?
Looks great.
Thumbs up.
Okay. Okay, so thank you, everyone. Welcome to my presentation on crash mapping and analysis, data and system architecture. The University of Wisconsin has developed an updated crash mapping and analysis system that consists of updating mapping application, and more importantly, what we consider to be an improvement to the application architecture. So a little history about how things came to be. The University of Wisconsin is in a unique position in that we are, or more specifically, the Traffic Operations and Safety Lab is the repository for all crash data going back to the 90s. And this offers a wealth of information for safety, planning, and research purposes. With regard to the topic at hand, the updates that I'll be discussing include daily updates of real world coordinates, and also, since we didn't want to recreate all of the different moving parts in the application, we were striving to integrate with the existing model. For the purpose of what was been done here, there was no need to change the database structure or a perfectly functional query facility. Additionally, we improved this by creating a service-based framework to allow access to the crash data, excluding sensitive information, but allow crash data access for the purpose of creating third-party applications. The prior application had two components. First, the crash data query facility, and this part hasn't changed. The other part was the Whistler, Wisconsin Information System for Local Roads crash map. The issues that we addressed in this effort is that previously the two components were very tightly coupled. There was no way of external access to the crash data itself outside of going first through the crash query facility and then subsequently displaying the map as it existed in the application. Also, mapping quality issues. The crash points were derived from a linear referencing system, and I'll discuss more about the issues that were related to that. I also mentioned there were no external hooks to access the crash data. There wasn't any way for third-party applications to use the crash data directly. Access to the database was entirely contained within a monolithic application. The web framework that we're using, it was very old. It seemed dated in the modern era of easily zoom and pan maps. It looked out of place. And also there was a time-consuming manual update process. Say a crash was updated after the fact, that required analysis to go back and reset the coordinates, or rather the linear referencing information required to generate the mappable coordinates for the crash point. So going back through history, from 98 to 2010, the crashes were only mapped to the center line of the state trunk network, or the STN. At least anecdotally, the STN is considered to be a pioneer of linear referencing system. It's based on routes, links, and finally chains, which is the spatial representation of the roadway geometry. At the time it was created, it seems like the mapping component, the spatial component, was something of an afterthought, but it has stood well the test of time. Even now, this was created in the early 90s, and it still exists now as the production linear referencing system for safety data, planning, construction, and any number of other roadway attributes. However, the state trunk network, it had very limited coverage. And continues to have limited coverage. It only includes interstates, U.S. and state highways. Moving ahead to 2011, things got better. Increased coverage by use of the Wisconsin Information Systems for Local Roads, and that includes everything. It's a superset of both the state trunk network and local roads as well, including county and some smaller roads as well. However, the crashes were still mapped to the center line by means of coordinates derived based off of the linear referencing system information. Talking about how the linear referencing system information was generated, very time consuming. It involved a process known as a reference point, or RP coding. So given a crash, an analyst would need to look into the crash report and attempt to derive the location from that. And given that, would identify a reference point, a fixed location with a known linear referencing value, a route and a distance along a given route. And from that, would add that into the crash database. And only after that could the coordinates be derived by a process involving the chains, the geometric representation, the spatial representation of the roadways. This worked well enough. However, the state trunk network and also the Wisconsin Information Systems for Local Roads rely on a number of lookup tables, from routes to links to chains. And the referential integrity is good, not perfect. So that did result in quite a number of unmappable crashes, crashes for which we weren't able to derive any real world coordinates, latitude and longitude. And also, using these crash reports, the location was subjective. It depended on an analysis interpretation of what was included in the crash report to define location. In 2017, things got a lot better. Now, a part of the crash report is, and this is all done electronically by law enforcement in the field, a part of the crash report is coordinates. They take GPS coordinates of the location as they determine it to be, and that is a component of the crash record that's included in the database. It's greatly reduced the number of unmappable crashes, and also it improves spatial accuracy. There's no longer the need for the subjectivity of analysts to try and interpret a location, but rather those are defined by law enforcement in the field. And additionally, the crash points are no longer tied to center lines. If a crash were to happen on a median, on a breakdown lane, it would be reflected in the database. The new architecture provides for much more complete data accuracy and almost completely reduces unmappable crashes. And there's a better representation on dual carriageways, as it's no longer tied to a center line, and a lot of time savings. So the updates, and specifically after the fact updates to a crash report would have required manual updates by an analyst. And also, it uses a known data source to the extent that the law enforcement correctly identified the crash coordinates. That's what we have, and also, again, it removes subjectivity on the part of the analyst. So this slide, bear with me, it's a bit difficult to explain. So think of, as previously mentioned, there was a big change in 2017. Now think of trying to derive the coordinates as if that change didn't exist, if we didn't have the law enforcement provided coordinates and only using the linear referencing system. So on the top image, that's as if we were just using the linear referencing system to define the coordinates, first by the RP coding process and then deriving the coordinates along the line work. And below, the improved system, the same crashes, but as using the law enforcement derived coordinates. And below, first, take 2017, for example. In the first three columns, we have, well, first we have the total number of crashes and the new CMMA system. This is the number of crashes that could be mapped using the new process versus what would have been mapped using the old system, just based on linear referencing system. So a dramatic improvement. Using the old system, we would have only been able to map this around 68% of the crashes, and using the new system up to 92%. And in 2018, things get even better. Previously, we would have been able to map 73% of the crashes, and now we're over 95% of the crashes that can be mapped. So changing gears here, this is the crash data retrieval facility, and here any number of filters are provided that a user and an analyst can come in, select the crashes that they would like to see displayed by county, if it's an intersection crash or not, date range, and injury severity. And this is just the basic view. In the advanced view, there's far more filter criteria that can be specified. But this part has not changed. It was working perfectly well as it was. We wanted to leave this component in place, but update other components of the project architecture for better results. After the previous screen, a user would be directed here, a tabular view of the crash attributes. And I'll direct your attention to a blue rectangle. That is where the next step happens. Well, what would happen previously is a user would be brought to something that looks like this. I mentioned a dated user interface. This certainly is. It was built on Esri's Web ADF framework, and first, it's deprecated. It's no longer supported by Esri, and even if it was, a modern user would come and look at this and see that it doesn't look like something modern. It used server-side rendering. That means that the crash points are rendered server-side and provided to the client application, the browser, as a single image. This does have some efficiency advantages in that it's the server that does the work and it doesn't bog down the browser. However, advanced selection or even selections or things like pop-up info windows requires a round trip to the server because the client doesn't have that. All it has is an image representation of where the points are. Additionally, it was a tightly coupled framework. There wasn't any side door into the database to the crash data itself. It was a straight shot from the query facility into the map, but with no opportunity for external developers to or third-party applications to access the data. The improvements that we were looking for were, instead of a tightly coupled monolithic application, we used ArcGIS Server geoprocessing services to support the mapping component as well as additional applications. There's a distinction between map services and geoprocessing services. With regard to ArcGIS, one would be most familiar with map services that expose geographic features from background data sources, either as a server-side rendered image or as parsable text. But in this case, the geoprocessing service is doing something similar by returning the text, the geometry and attribute representation as text, but instead of a map service, it's as a tool, much as if, for those familiar with ArcMap, that you would provide a tool in Arc Toolbox with a number of parameters, one or more parameters, and then it would return something. In this case, it takes a query ID which runs against the database by means of a custom Python script to return the crash features defined by the query facility, the query parameters defined earlier. But also, the client interface has been improved as a modern web map with advanced selection tools. Here is a diagram of our new architecture. So starting with the left side, show CMAA map, going back to the crash facility, the tabular view, that is the button that one would hit to launch the mapping application. And from there, I'll skip through many of the details, but focusing on at the top, the web browser, the CMAA crash map with a red circle around it. This was built using OpenLayers as an alternative to Esri's JavaScript API. This allowed for a bit more of a learning curve, but it provided for vastly improved performance. Client-side rendering has its drawbacks in that once you get to so many features, then the performance of the map it really starts to struggle. However, using OpenLayers and specifically the WebGL variant of the renderer, we were easily able to render 150,000 points with the option to view as clusters with no noticeable decrease in the browser's performance. Once loaded, the CMAA crash map has it built into the code. It has a known query ID that is then passed to the ArcGIS Server geoprocessing service, here indicated with a green rectangle. Now, this is our services tier. It accepts that as a tool parameter, a single tool parameter, and it runs the operations against the database and returns the information as text, Esri JSON text, back to the client for client-side rendering. This services tier, this is where external applications could be added. The services tier is also the service used by the UWCMAA map is quite specific to the application, but more general geoprocessing services that could be added later at this tier to support additional applications. Well, for those familiar with the services directory, the online services directory for ArcGIS Server, this will look quite familiar. An advantage of this is not only are we exposing the services, but it's also, in a sense, self-documenting. Similarly with map services, there's the allowable operations on a map service are available here too. The required parameters by a given geoprocessing service, a geoprocessing tool, are defined on this services directory. So it's a way of both exposing the services, but also providing to the potential end users how to use it and what is returned. Well, here's an example of the result set, again in Esri JSON format. And this is a common format that's easily interpretable by client mapping applications, or alternatively, it could be converted to GeoJSON for those applications that don't handle Esri JSON natively. So at this point, I'm going to break for a demonstration of the new crash map. Starting with our crash facility here, I'll just do a simple example, taking crashes in 2019 that happen in, let's say, Buffalo County. We retrieve that data, the count is 2034, and by clicking on CMAA crash map, I'm going to, it automatically opens in a pop-up. I'll switch to a full screen window. And here we have all of the crashes, and we have pop-up information available. I won't click on this, but direct access to the crash reports. Early on, it might have been a scanned paper copy, but later it's more of a PDF format derived from the full crash report with officer observations and all the observations that are associated with a crash, and that makes this easily accessible in the context of a web map. If we want to do some more advanced analysis, so let's say that we were interested in the crashes that happen in this area and also in this area, we can do that. There's options for advanced selection techniques like add to selection, remove selection, subset selection. Just some really handy tools that it wouldn't be available had we been rendering this server side. And once we have our selection created, we can download a CSV, again, of the selected crashes. And there we have a full attribute set. And the number of columns and which columns are included in this are configurable by the user. We have a number of presets for the attribute information that would be returned. So recalling that this information derives the crashes from this geoprocessing services tier. We can also create additional services. This specific map uses a query ID. It's very tightly coupled with this application, but a more general purpose application that was created in using AGO in just a matter of minutes, but using an alternative geoprocessing service. We can select, let's say, 2 counties and start and end year. If we run this, we'll be presented with the results, as well as there's also some built-in graphing and graphing widgets. So, for example, the injury severity, the KAB, the O crashes are property damage only. They're just some really nice features that use this geoprocessing service services level tier to create external applications quickly, and also for individuals that might not be too into GIS, but can certainly create a map using AGO's web app builder. So I discussed our crash map created here at the UW, the AGO example. And with that, I believe I've concluded. So thank you for coming and invite any questions.
There are quite a number of questions actually, Glenn, so I'm just going to start reading them. We'll get a couple of them answered, and then I think we're going to go on to the next presentation soon after that. But in the meantime, when roadway alignment changes as part of roadway projects, do you retire the crashes on older road alignment? How do you save and retrieve old alignment and crashes geocoded to old alignment?
A very good question. There is, within the STN and the State Route Network and the Wisconsin Information Systems for local roads, there is an additional table called link history, and that allows moving forward from the previous alignment into current alignment. Now, that's one of the catches. Say in a case where there isn't any reasonable, imagine a complete realignment where there isn't any reasonable translation from what existed previously into what is there now. That's a case where things would break down and we would end up with an unmappable crash.
Okay. For crash reports, are you using the location provided only by law enforcement and not performing any analysis to make sure that the location is accurate?
There are some checks. Very rarely will an analyst come in and check, look at the crash report, and say that the law enforcement provided the incorrect coordinates. But for better or worse, we have something that we can say that this is it. Law enforcement said it was here, and who is it for us to say that it's anything else than that? But to do that level of change invites scrutiny. And so to the extent that we can say that law enforcement provided the coordinates, we know they may not be perfect, but that's what it is. So it absolves us of responsibility for altering original data.
Okay. Did a vendor or university create your new crash data site?
The crash data site, the Queer facility, that comes before my time. I'm quite proud to say that I made this open layers map, and it's working quite well.
Very nice. And are the coordinates required as part of the police crash report? If coordinates are not used, then is the location entry a manual? There's another word, but I can't scroll because I'm using the wrong button. Effort.
So you may have noticed that even now, after 2017, in the tabular summary, there's about 95% of the crashes that are mapped. That other 5% are those for which law enforcement did not provide coordinates. So this goes back to an earlier question. Law enforcement that provides coordinates, they're most likely correct, and if they aren't provided, then we don't take the effort to assign a location, except for cases that it's a really big one, say a fatal crash, severe injury crash, and those are also the least likely ones that would have incomplete crash report records.
All right, thanks, Glenn. That was a really interesting presentation, and if there are more questions later, we'll come back to them, but I'm going to turn it back over to our lovely host, Nicole, and she's going to introduce the next speakers.
Thanks, Penelope. So we have Marshall Stevenson and Jesse Day from Maryland DOT. They'll be talking about what they've done to modernize the Transportation Authority's Freeway Incident Traffic Management Plan. So it'll be really fun to listen. So I'm going to pass the presenter. Am I giving it over to you, Jesse, or you, Marshall? I'm not sure which one.
I think we give it to Marshall. Is that right?
No,
Marshall?
Actually, it's Jesse.
Jesse,
Right.
okay. Okay, heading over to Jesse now.
Okay.
You see your screen and your beautiful sunset.
Okay, then you look at it. You see the webinar invite?
We don't see that because that never shows, but we do see the presentation.
Okay, let's see. Do you see the PowerPoint now?
Nope.
Okay, I got to switch screens just a second. No, that's not it. I did this yesterday and it worked fine, and now it's not.
Did you try sharing your application or sharing your screen?
I'm trying to, oh, I found it, sorry. It was a right mouse click. You should be able to see the PowerPoint now.
Perfect. We see it.
Okay, let's go. Okay, we're here to talk about the Freeway Incident Traffic Management Plan modernization. Also on the call is John Private. We call him JP. He is a project sponsor with MDTA, and he may chime in from time to time. Marshall Stevenson is going to be given a live demo of a web app or actually an operational dashboard we've developed, and for basically digital use. So let's get going. Here's the outline, and this basically is telling you what I'm going to say, so I'm just going to jump right in and say it. First of all, let's talk about Maryland State Highway Authority, the One Maryland, One Centerline project. And I bring this up only because the FITM project would not have been possible without this project laying the foundation. And so what this was it was a three-phase project started in around late 2015, and it was a migration project. We migrated their legacy systems over to roads and highways, and they had a legacy roadway centerline file. It was using Esri's first generation LRS. And then they also had an Oracle homegrown characteristics database that they called the Highway Management Information System, HMIS. Now I think there are several things that I think are markers for a project success. And one of them is, does the system grow outside of its initial purposes? And that's what something is happening just naturally at MDSHA. We've started a striping project. We're pulling striping data in from the maintenance folks. We're pulling bike paths in from the guys that do bike path data. We're pulling structures from the bridge folks. We're piloting a pavement project. And of course, there's this project, which was the MDTA FITM. And MDTA is actually even outside of the organization, outside of MDSHA. So I think this is I think a sign of a really successful project and one that's really healthy at the time. So there was also a second phase, local data integration. And this component of the project has really changed and evolved over the last 2 years. And right now we are prototyping, beta testing an application that allows local governments to delineate the sections of the local roads that they've taken responsibility for. And they're also able to maintain their HPMS sample sections on local roads. And then the third phase was deploy data analysis and visualization tools. And we have a suite of tools. One is called Segment Analyzer. It's essentially a data merge tool. So, for example, in MDTA's case, we can take the detour routes and merge them with things like number of lanes, pavement condition, shoulders, average daily traffic, and on I can go. And so it provides this high level analysis on these sections of roadway. We also have a straight line diagramming tool, and this tool is a web-based tool and essentially just displays the data from map services. And so it's as current as your data is. They used HPMS Assistant, and they were actually, we went live with this project in February of 2018, and they actually, using this tool, they were able to meet the submittal requirements in June 2018, which I think was pretty good accomplishment. Then we've got Job Execution Manager, and I bring this one up because in combination with some Python scripts, we can use this tool to send emails to the traffic engineers when there's a change in network alignment, and it allows them to go back and look at these FITM plans and make adjustments. So let's look at FITM pre-modernization. The Freeway Incident Traffic Management Plan we're going to be looking at is one for Fort McHenry Tunnel, and this is the first one we've done. It's just, if you're not familiar with Baltimore, this is the tunnel right here. And this particular plan included 72 incident plans, and each plan consisted of an incident map, an incident narrative, a DMS map, a DMS description report, and all told, it was housed in 144 individual Esri map documents and 144 Word documents. Obviously a little unwieldy and hard to manage. Just look at some of the documents. This is one of the original maps. I bring this one up because it's a little more complicated than most. You can see it's not great cartography. You can see that here's their incident zone here, and it's almost camouflaged. And just kind of go over what this is. What they do is they identify an incident here, and then here, this is what's going to happen. These are all the detour routes in the event of an incident here. And these are all the critical intersections. Here's, for example, this is restricted truck traffic. And this is a narrative you can see where it describes the detours, it describes the stranded traffic, talks about standard traffic, emergency contacts, and of course, this is a list of the intersections that are impacted by the incident. And again, this is an action plan. That's just a narrative for the folks in the field to know what should be happening, what's going to happen in the event of an incident. And here's the DMS sign map. And this one, it's not a bad map if you like reading maps upside down. So anyway, of course, here is the DMS report or detailed report, and this just indicates exactly what these DMS messages should read in the event of one of these incidents and of a specific incident. To give you an idea of the before and after, here's the before of the map, and this is the new map that we created with the data-driven pages. I think cartographically it's an improvement, and it's a lot easier on the eyes. I think we've worked with making sure that the symbology is appropriate, and it's easy to find out where the incident is and what the detours are doing. Let's look at data cleanup, data model, and migration of roads and highways. The data cleanup was taken on by a senior GIS analyst from Rising. Her name is Logan Erickson. She did the initial analysis of the data and developed a 29-page data cleanup procedure. There was no available institutional knowledge of the data, so we were on our own, or Logan was on her own. And so she figured it all out and developed this procedure. And then she also oversaw the cleanup team. While exceptional, the GIS analysts with WPCM were really good, but they really didn't have any LRS experience. So the data cleanup procedure had to be explicit and provide an example of every cleanup scenario. So let's look at this. For example, we had to start from scratch and teach them what a roadway ID is. In this case, a concatenated roadway ID. Here's a narrative of a certain situation where there's a DMS sign. If you can see, it was snapped to the westbound lane, but you look in the description here, it should be on the eastbound lane. And so the analyst would go in here, look at it, they would update a comment here and get it moved over to the right place. Now there's a lot of, I'm not going to read this to you. Basically, this is a narrative of the whole process, how we move the data from the source into roads and highways, but we'll just talk through it with some graphics. Here, and for some reason, we still don't know why, but this incident data at its source was polygonal. So what we did was we actually increased the size of the polygon buffer, put another buffer around it, and so that we could make sure it stayed in the alignment, because we didn't, the vintage of the network that they were using was unclear, and it was at least probably 10 years old, but we're not sure actually. So we were able to overlay this polygon on the OMOC alignment, and we're able to, through the geo process, identify what the from and to measures were. And this is an example of a clean one. This is the one that's not so clean. You can see this actually involved two different roadway IDs, two different segments, and the alignment's off here at the top. So the analyst had to come in and move it out to where it belonged. The data model is actually pretty simple. We only used or introduced 6 new events, incidents, detours, ramps, DMS, truck restrictions, and intersections. And then we have a series of what we call information tables, where we took the narrative data and put it, from the Word documents and put it into these tables, and then use our reporting tool to generate that. And then there's a series of lookup tables. And that's what the lookup tables really were so that we can normalize the data. For example, we have this one detour route actually is used on 5 different incident plans. So we needed to, to normalize it somewhat, and so that we could just have, one detour, but use it on multiple maps. Data-driven pages. I don't know who all out there has used data-driven pages. but don't be afraid of them. They're really easy to use. You come in, you identify a layer that you want to use for your extent. You identify a field for the name of the page, the sort field. You can rotate. If you want to, you can introduce another spatial reference. And then we didn't use the page number function. We used our reporting tool to provide that. The dynamic text is really easy to use, and we only used it here for the title. You can see in the sort of in this code here, you can see we're using the incident number and the incident description to provide the title for the map. And then the legend, again, real easy to use. You just define what layers you want in your legend, and of course it inherits the symbols from your map document, and you apply and you're ready to go. And then within the layers, you go to an individual layer. For example, this is the layer properties for the detours. And so within that property, you define the field name that you'll use to filter out or filter in, as the case may be, to filter in those particular detours that apply to that specific incident. This is a little code that we downloaded from Esri's Esri website, and we use this to export the PNG file of the map that we then go on and use in the report. Here's our cartographic approach, and it's real simple. Hands off, let data-driven pages do the work. We had a couple things we had to deal with, for example, these call-outs. We felt like to do this would require someone to get in there and do them one by one, and it's just, so what we decided to do is go ahead and we got a from Maryland's IMEP portal. They had some of these cultural features, and we just able to pull them in. And the end result, I think, is a better product or a better looking product, a lot easier on the eyes. We just have, you can see where there's schools and a firehouse and that kind of thing on the map. These are the narratives. Again, here you got we've looked at this. And these are the automated narratives, the ones that are done in the report, and they pretty much duplicated the look and feel of the old analog versions. Again, these come from these information tables and the lookup tables. And this is the DMS report, again, that came from the actual DMS lookup table. And the report engine, this is one of our tools, and it's a web-based application. You simply come in here, and you can have any number of folders in here. For example, you could, for different offices or different parts of your organization. And you simply click on the MDTA, and this one on the MDTA folder. And we skipped a little step right there, but in this one, we'll go one more step, and then you come to this page, and you just type in the incident number here, and literally it generates the report as quickly as I'm clicking through these PowerPoints. 1, 2, 3. I mean, it's lightning fast. And we'll go back through them here. Okay, project objectives. Some of these objectives I pulled right out of the project scope of services, and one of them is this one, the automated network change notification. I mentioned this before with the little Python script, and then our job execution manager will use those tools, so there's those functions to notify the traffic engineers when there's been any change to the network, because it's happening in separate offices. Jerry Einhoff and his group, and the data services division, and with MDSHA, they maintain the network, but MDTA folks will be maintaining this FITM data. And of course, using an event editor, they can just do it right from their desktop. Once this RNH data, the roads and highways data is in RNH, then we can use it for these advanced analytics, which I mentioned with Segment Analyzer. Again, so you can grab, for example, either an incident zone or a detour route, and look at it and merge it with other data, ADT, pavement condition, number of lanes, so on and so forth. And of course, here the incident data is now available in map services for use in the FITM map application, which you're going to see in a couple minutes, and Marshall's going to be demoing that. These aren't bold because they really, I think, were not mentioned in the scope of service, but I think they were part of JP's intention. And one is to simplify map production, which we've done with the data-driven pages. We wanted to be able to do push button plan generation, which we've done with with the report engine tool. He needed or wanted to establish maintenance plan and procedures, so that basically for continuity as time goes on, and that these things are just as good, a year from now and 2 years from now as they are the day we first publish them. And then there's comprehensive how-to documentation, which is important, very important to JP, and that, you know, there's always turnover in every organization, and there's reorgs and people move on. And so we will provide a document that really, when a new person walks in the door, it's like, here you go. And it, you know, you go through the document and it'll tell you where, if you don't know something, for example, if you don't know roads and highways or an event editor, then maybe you're going to need to go to training. And with that, I'm going to go ahead and pass it over to Marshall. And so Nicole, can you go ahead and give Marshall control, please?
Yes, I lost my stuff here. Hang on. Will, I cannot seem to find to transfer that over. I don't know if something stopped when Penelope left.
Hold on, I can see it online. Let me look. Okay, I did it.
Oh, there you go.
Yep, I did it.
All right. Can you see my screen?
Yes.
Seriously? Okay. I wasn't sure.
I really see it.
Okay. All right. Thanks, everybody. Just going to kind of show you one of the outputs, so the end products, and being our operational dashboard that we built using Esri's operational dashboard framework. So going to go through it. We're trying to keep it very simple. Just to preface this is still under development. It is not a production application at this time. They are not using this yet, but this is one of those things that they wanted as a deliverable, because right now, as you noticed, what Jesse was showing was very paper driven or PDF report type driven. Having that information accessible from multi points, and the dashboard being one of them, and not just a printout, you know, in a binder in a truck, but also having it quickly accessible on the desktop as well, especially from the operations center perspective. So this is what you're going to get when you launch the dashboard. Already loaded it ahead of time. There are different facilities or different roadways that MDTA maintains, or sections throughout the state. You could go in here and pick essentially your facility, being the Fort McHenry Tunnel, being this is the one that we've currently worked on. Then as soon as you go through that, you'll get a drop-down list of basically everything that is in there. I can search in this. I can just go, you know, FMT N1, you know, go through these if I type them incorrectly. But there I can pick it from the pick list. When I go through the pick list, it'll take me right to that specific incident area or incident zone. It'll also launch, if you saw the cameras change. So everything that is in the map view is changing in the dashboard. The incidents, there's nothing, I was hoping, I'm not saying I'm hoping, but there was an incident yesterday here, but obviously there's nothing going on today, so it's pretty quiet. But if there was an incident below the camera, you would notice incidents that would be listed here. You can then see when we picked the N1, automatically popped up was actually it's just a PNG of the incident, but you can then just quickly go in and click on that map, and it will load the incident plan and have that accessible right there on your desktop as that, you know, PDF type document. So it's very like I said, keeping it very simplistic. But everything in the dashboard is very dynamic. There's a lot of other data elements within the dashboard. We have, like I said, I'll go back actually. Let me zoom back out here, and I will show you, you know, the scenarios if there was an incident. So right now, there's 3 incidents in this dashboard within this map view, and you can actually see they're all kind of clustered over here to the east in the view here. You can click on one of these, and I'm just gonna, like I said, roll the dice here because this is all live data as far as coming in from the incidents that are being reported. But you can notice it'll zoom to that incident. We actually have the DMS signs labeled with what the information that's currently displayed on them. You can actually scroll to other cameras in here. So in this map extent, there are 3 different cameras that might be relevant to the incident. And you can and quickly page through those based on the geographic extent of the dashboard. So you can click on other ones here. It'll take you to that. If the cameras change based on the view, so right now we're down to 2 cameras based on that incident within the view itself. There's other data elements that we've pulled, from Esri and other various sources. We have the traffic congestion layer you can see on the map. We also do have our signals, so data. So if there was a signal outage in an area, or we would zoom to that area, it would appear, and you would have that information there of a signal outage event. And if there are any weather alerts too. As Jesse said, it's a tunnel for this incident, but there are there's other structures and bridges in this area that might be subject to, let's just say, high wind warnings and things like that. We do also have integrated into this a lot of other layers. Some are on by default, but other relevant layers that might be useful in the dashboard can be turned on. They're like I said, automatically turned on if they need be. We do have a radar, a weather radar, stream gauges. Another thing we do have in here is anything winds over 24 miles an hour, because wind could be a factor. So if I'll actually travel down here, since we're pulling in this data just from Esri, you're going to see, I'm just going to venture down here. There's a little activity going down on the south, which I'm sure some of you might know of right now or be partaking in. But all this information is showing up in here, and obviously there's no cameras in this area, but we do have information here. So you can see here we have weather information that's pulling in. So we're only showing anything over 24 miles an hour in this weather feed from NOAA. We have other weather related alerts, but just showing, obviously it's pretty quiet in Maryland right now, so I can't make that much of it, but it will be dynamic as far as what you're seeing in the map as you're navigating the experience in the dashboard itself. That's pretty much it. Keeping it, like I said, pretty straightforward. These are not technical folks necessarily that will be using the dashboard. So within pretty much 2 clicks and not much else, they'll be able to get to the plans and access them, and with a wealth of other information visually at their fingertips. That's it.
Thank you, guys. So I was having problems seeing the questions. Will, are you able to see those questions? I know we must have a few.
There are a couple questions. I have a few questions.
You're still there at Penelope.
I'm still here. So a question that came in is, does the documentation for data-driven pages and dynamic text provide instruction or examples?
Well, first of all, Penelope, let's not pretend I'm the one that actually developed those data-driven pages. Those data-driven pages were done by 2 of our senior GIS analysts, and that would be Logan Erickson and Emilio Rockwood. But the document, it is very well documented. And I actually, this morning, because I had some questions about how things were working and how it works. So I went on and I was able to find the documentation to be very robust and easy to use. So yeah, there's like a little code snippet that I showed on the dynamic text. That's all there in the doc.
And here's a question, is the dashboard out of the box or custom?
Dashboard is totally out of the box. Nothing's custom. It's pulling in services, various services from all different locations, both internal to SHA, public facing, Esri services. It's a combination, and the whole configuration is out of the box.
Okay, and I want to encourage everyone who's attending the webinar to go ahead and send questions in for any of the 3 presenters. All 3 of them are still here. There is one more question for the Maryland team. Is Maryland, the MDTA, considering moving away from paper maps and going all digital?
Marshall, you want to field that? I can take a crack at it. I think.
You know, I think even I could answer that one with my knowledge of Greg Slater. I'm sure they are planning on going all digital.
Yeah, I mean, I think in generally speaking, everybody's trying to get to that all digital world. But we also know that, certain things lend themselves to paper for ease of use and operation, and also just, being in a truck, you know, and being able to go through some pages. I mean, some of our users are used to, you know, more of the manual paper-driven process, so change can always be a challenge. But I can definitely tell you that working with our various stakeholders at SHA and MDTA, they're all very much becoming more and more interested in going digital.
Right. And I do not see any other questions for any of our presenters today, who all, I think, did a very spectacular job. As people who attend these sessions regularly know, we did record this session, and we will be publishing the recording together with all the supporting documentation, the presentations themselves, and links to the live demos on our website soon, within the near future, hopefully before the next one. I'm going to turn it back over to Nicole so she can lead us out. And just remember, if you know any friends that you think that would be interested in attending these GOTUG webinars, please send them to the gotug.transportation.org page, where they can self-register to receive the Constant Contact email and notifications of webinars. We don't send a lot of information out. You won't get spammed. Pretty much you're going to get 2 notifications every 3 months, and those are going to be just ahead of our quarterly webinars. So Nicole, take us out.
Thanks, Penelope. So thank you guys again for attending. I hope you guys enjoyed all these 3 presentations. I know I did. Our next one's going to be LRS Meyer. So that's going to be, I'm really excited for that one. So it'll be fun. Looks like on one side we said December 2nd and the other we said December 3rd. So I'm going to go double check my calendar.
It's whichever one is the Wednesday.
It'll be December 2nd. So don't pay attention to the date on the slide. It's December 2nd, that first Wednesday in December. And that one again will be LRS Meyer. So if you're, you know, all you guys are here, you're signed up on the link, so you'll get that information about that webinar coming, and share it to those you know who have an interest in Meyer and LRS, so that way they can participate and see what's going on. Thank you again, and have a great day.